A branch locally is you create a branch, or a diversion in your code. Is you create a branch, you do some commits, you go back to where you started from, you create another branch, you do some commits, you just do some commits, right? And so that way you have work that diverges, that goes off in two or more different directions. So if we create a branch, do a couple commits, go back, create another branch, and then do a commit, right? It'll be based off of the same base that this one was. So we'll have the code going off in two separate directions. So issue 53 now goes off. So the reason why you would do this is if master is, I'm fine. If master is your stable code, this is what you push out in production. And you want to work on an internationalization feature, so you create a branch, you do some work on it. It's not finished, you don't want to merge it in yet. But somebody comes along and says there's some problem with the code in production. Now it's nice because you have a pointer at what's in production, right? You don't move like in this case, let's say, you don't move master unless it goes out to production. So now you always know what production looks like, right? Or what is last shipped or something. So now you can go back to that state and say, I want to create a new branch here and fix that bug based off of that, not based off where I currently am, which could have, you could have already changed what the bug is or something, right? So now we go back, create a new branch, we do a commit, we do some more work, we do a commit, and we fix that bug now, right? Based off of master. So now, this is what let's say that this is what all of our snapshots look like. We have, can everybody read these? I don't know how small this is comparatively. So we had readme and hello, and we created an IETN branch, and you can see just by comparing stuff that on the IETN branch, we added a new file in this one, right? This is basically what Git does, is after the fact it just looks at what the snapshots are and it figures out what happened. So here, readme and hello did not change, but we added a new file. So we added a new file in that one. And then in this one, readme did not change, but hello changed and IETN changed. So we modified these two files here. So we can see how they differed by just looking at the differences between these content, right? Asking Git for the content and diffing them. Now, on the issue 53 branch, we did something different, right? On the first one, we added an issue.c file, and on the second one, we modified that file, and we did not change readme or hello in either of those commits, right? They're exactly the same as what we started with. So, we can see that issue.c was added in this one, and then it was modified in the second one, and we can see that IETN was added in this one and then modified in the second one, and hello.c was modified in the second one as well. So that's what we did, given this history. So that's fine. So now, what we want to do is merge. So let's say that we want to issue 53, whatever that issue was, we fixed it now, right? The running tests on that last snapshot, everything works out fine, so we want to ship it. We want to make master, we want to merge it into our master branch, and we want to ship it out in production. So we say git merge. So git merge is the last. There's git branch, git checkout, git merge. That's basically all of the branching tools that you're going to use. Now, git merge will do two different things, and we'll go over both scenarios. So in the first scenario, we say, or in both scenarios really, the process is git checkout master, or git checkout whatever you want to merge into, and then git merge whatever you want to merge in, right? So we want to merge issue 53 into master because that's our main branch. Issue 53 is done. We want to merge it in, delete it, and master will have that now, and we can push that out with that change, okay? Does that make sense? So I ask you if it makes sense, and I immediately turn away from you. Does that make sense? I don't know. So we say check out master, right? Because we have to be on one of the branches. You can't do a merge without being on. You can't merge two branches, one of which you're not on. You have to be on one of them. So you say check out master, this is the one I'm on. I want to merge in issue 53, so you say git merge issue 53. And I don't know if you can see the sort of subtle highlighting difference there, but what Git does is it looks at the one you're on and the one you're trying to merge in, and it says, is the one I'm in a direct ancestor of the one I'm trying to merge in, right? Can you take the one you're trying to merge in, walk the parents, and then find the one you're currently on? So in this case, we can, right? Issue 53 master is a direct ancestor of issue 53, or vice versa. Issue 53 is a direct ancestor. That commit that it points to is direct ancestor of the one that we're currently on. So it doesn't have to merge in separate trees. One is newer than the other. It is directly based on it. So it doesn't actually have to do any merge work. What it does is it's called a fast-forward merge. So if you see the phrase fast-forward merge, that means you're trying to merge in something that is based off of the one you're trying to merge into, right? So since F30 is a direct ancestor, it does a fast-forward merge, and all it does is update the pointer, right? So, and it will make your working directory look like this. But basically it's saying there's nothing, your work hasn't diverged. It doesn't actually have to merge anything. It just updates the pointer, changes your working directory, says, okay, now master's up there, and we're good. We've merged it in, right? It didn't actually do any merge work, it just moved the pointer. But as far as Git's concerned, it's merged. Now, if we say, I want the I18N changed too, I want the internationalization branch as well, now it asks the same question. Is I18N a direct ancestor of master? No, it's not. You can't go back through the history of I18N and find master, right? So it wasn't based off of master. So now it has to do a merge. It actually has to merge trees. So now this is called a non-fast forward merge, right? So that's, if you see the term, that's what it means, and it's really helpful term to understand, because when you're at this point now, everything you get is about reachability. Can you reach one commit from another, right? What is the parentage and the history? So Git merge I18N, they are not direct ancestors, so now Git will do a three-way merge, right? It will, just like if you have 3 directories on disk, it will take these 3 snapshots and use them to do a three-way merge. So the way that it figures this out is it goes through the history of both until it finds the first common ancestor, right? So no matter what the history looks like, you can always just go through. In fact, you can ask Git what the first common ancestor of any 2 commits is. And sometimes it'll be one of them. So in the case of master in issue 53, it will still do the same thing. It'll say, what's the first common commit of master in issue 53 when master was back here? And what's the first common commit? It's master, right? The first common commit is one of them. So that's when you have a fast forward merge. Now, in this case, the first common commit is not one of them. It's it does find something in common, which it almost always will. And it will find something in common, even if it's the first commit of the thing, right? It'll find something in common, and it'll do a three-way merge between these 3 trees. So now we can actually look at the trees and see what Git is basically going to do, right? In this case, for all 3 of these, README is the same, right? So it doesn't need to merge that. Here, all 3 of them have hello. In this case, on the I18N branch, hello is different. The snapshot of hello is different. On this one, it is exactly the same. So what's Git going to do, right? It's going to just choose this one, because this branch didn't modify it. It doesn't care about it. It didn't try and change it. So it's just going to choose this version of hello. And then it can see that each side has a new file, right? So all Git's going to do in this case is say, I'm going to just choose this hello. I'm going to add I18N. I'm going to add issue, and I'm going to leave README alone. And it's going to create a snapshot of that. And it doesn't actually have to do any merge work, right? Because the only time it actually has to do, it has a merge conflict, is if you change hello on both sides, or you change README on both sides. And when it tries to put it together, you try to change the same hunk of the same file, right? So then it gives you a problem. But other than that, if it can figure it out, then it will. And it will do like renames and stuff. So if you changed hello.c to hola.c and hello.c, and you modify both of them and merge them together, it will see the rename, merge it automatically, choose the one that changed, merge it for you, and then give you the file. And it can do it without even having merge conflicts if you didn't change the same part of the file. So you can do really complicated merges, and Git is generally very smart about it because it does this. It automatically figures out the merge parent, the merge base, and and you don't have to manually do it, right? So now it will create the new snapshot. There's a couple different things different with this. One is this commit is called a merge commit because merge automatically creates it, and it has 2 parents. It points to both the one you merged in and the one that you were on when you merged, the one that it merged into. So it points to both of them. It remembers that both of these were direct ancestors of this new one, and then it moves head up, whatever head's pointing to. Right? So in this case, you're on master, so it'll move master up. If you were on issue 53 at the time, and you merged in I18N, it would do exactly the same thing because the same 3 snapshots are involved. The only difference would be issue 53 would move up rather than master, right? Because they were at the same place. Does that make sense? So now if you check out master, And if these were reversed, if you checked out master, it would look like this. And if you checked out issue 53, it'd look like the other one. So the only difference in the branches is what snapshot they point to. Right? Okay, so now, I don't know what I'm pointing out here. Oh, yes I do. So the only difference, so when you did the merge, what actually happened was hello.c changed, right? It chose this version. IETN was added from the IETN side, and then from this side, issue.c was moved over. So that's all that actually changed there. Now, reintegration merges. So this is where Git really differentiates itself from the merging that you did in Subversion. In newer versions of Subversion, it had merge tickets, or SDK or something had merge tickets, and you kind of do that okay. In older versions of Subversion, you had to figure out the merge base manually, right? And so that was really the problem with Subversion. Now, Git does it automatically. It knows the history, and it can figure out the merge base without you having to get involved, so that's fine. But now, here's another thing that Git does very well, which is reintegration merges. So now, we've already merged in issue 53, we merged in IETN, and so now master has both of them, right? Everything is incorporated. So now we say check out IETN, and we change it again, right? We do some more work on it, and we commit again. And then we check out master, and we merge it again, right? So this is a point where you would normally have a problem with Subversion, trying to do this, or trying to do it multiple times, right? Subversion is simply not good at this. Git's very good at this because it does exactly the same algorithm. Because this merge commit has both of its parents, it walks the histories and says, what are the common commits? And it has two, right? It has this one. If you walk both of these, you get this one. And if you walk both of these, you can also get to this one, which is the original one. So it has two candidates. And so Git will choose the closest one, which is this. And so if you look at these, the only difference is the README change, right, between this one and this one, right? So now it does a three-way merge. It says this is the same, README changed on the other side, so all I'm going to do is write the same exact thing but change the README, and we're good. And now master moves up again. And you, again, don't have a problem with this, right? You can continuously do this. Now the nice thing about this is that it allows you, well, to try out ideas, right? So in branching in general, like I was saying, there's a couple different ways to use it. One is you try an idea. You say, I don't know if this IETN stuff is going to work out, so I'm going to try it, or I have a dumb idea, I want to change the background of everything and see if that works. So you create a branch, you do it, you show people, if they like it, you merge it in, if they don't, you just delete the branch pointer. You still have the commits and stuff in your database, but nothing points to them, so you've effectively discarded them, right? You could get them back if you needed to by just dropping another pointer back, but effectively, you can't see that work anymore. Now, that's trying to get ideas. So you can isolate work units. It's very easy because it's easy to switch branches in a single working directory, and it's very fast to create them and delete them. It's nice to isolate work units. If you have a ticket tracking system, it's very common to have a branch for every ticket that you're working on, right? So for every single ticket, you just say, create a branch for that, work on it for 3 or 4 commits, merge it in, delete the branch. And all you're doing is removing the pointer that is already reachable from your master branch anyways because you merged it in. So that's what, and then you can just switch back and forth and not have to worry about stepping on your other work or worrying about your other work getting in the way of what you're trying to solve right now. Does that make sense? And then the last thing, and the thing that really differentiates it, is long-running topics. So if you had an IETN branch and you were trying to internationalize your entire code base, right? So you were using get text and you were wrapping underscore brackets around everything or something, right? And you did everything, and it took you a month to do it. And the main code base is being worked on by 10 other people, right? How easy is the merge at the end of that? No matter what merging system you're using, right? It's horrible. It's absolutely horrible. The nice thing that Git does is it allows you to merge constantly, right? You can be on an IETN branch, and somebody else can be updating the master branch, and you can merge every single day. And the only you will still have merge conflicts, but you'll only have merge conflicts between then and the last time that you merge.